two kind of sets of properties here. I've got what I call the simplifying properties. And the first one of those would be log base. I'm going to use A, but it technically doesn't matter what that base is. Log base A of 1 is equal to 0. So anytime you have a logarithm of any base of 1, then that's going to be equal to 0. So it's kind of like going to cancel out. Is what happens there. So that's a simplifying property out of that. The next one is one we've been using to solve some equations already, and it's where you take the log of the base of the logarithm is the same as this number right here, or letter, or whatever it is. So if these two match here, then they're going to cancel each other out and make a 1 out of that. If there's exponents up there, then that kind of pulls in another property for us. But really, that simplifies the logarithm out. It cancels it out and gives us 1. So base of the logarithm is equal to that, what you're taking the log of. They cancel each other out and make a 1. The third simplifying property, there are only 4 simplifying properties. So the next one is the one that we really have been using a lot, or use some on that quiz even, is where you have the log base A of an exponential with the same base. When you do that, this logarithm is going to cancel that base, and the only thing left is going to be the exponent. Whatever that exponent is what's left. We've used that some already, so that's a simplifying property. And then the last simplifying property is an exponential. If you have A as the base and then log base A as your exponent. So the exponent is the logarithm this time. So the base is A, the exponent has a logarithm in it. Then if it's the same as the base of the exponential, then they're going to cancel each other out, and all you're going to be left with is m, or whatever's inside of this logarithm here. So this log A and that base A cancel each other out. So we're seeing that happen a lot, that the logarithm and the same base on the exponential cancel out. So that's where your simplifying is going to happen. So when you have a logarithm with the same base as the exponential. So those are the simplifying properties. Now, the next ones are what I call the manipulating properties. Manipulating properties means you're making it look like something else, okay? So the first of those manipulating properties, and I'm just going to call this 5, is when you have a logarithm, it doesn't matter what base. I'm using base A here. If you're multiplying on the inside of the logarithm, you can manipulate that to be the sum of 2 separate logarithms. Multiplication can become addition, splitting it apart. You can go the other direction. If you have addition, you can put it together as a single log with multiplication. That direction, we're going to go both directions in when we're doing the properties today, but no, that's change of base. Well, then that's one of our manipulating properties too. But this one, it would be no. The difference in the change base is if you don't have the log base tool here. This could be any base here. It could be base 2, could be base 17. It doesn't really matter as long as we're multiplying on the inside. It can split it apart into addition. Okay, we'll get to that change base in just a second. It's the last one that we talk about here. All right, then so multiplication becomes addition. What does division become? Yeah. We take log base A of the numerator minus the denominator. Log base A. Again, that works with any base on the logarithm. It doesn't matter what the base is, as long as So there's division in there. You can make it subtraction. If you want to condense into a single logarithm, you can go from subtraction into division. Okay. And then property 7, this one is if you have an exponential that is not the same base. And I'm just going to use them in R. It doesn't matter here. Notice this is not the same as this one over here because this one had the base being the same. The base of the logarithm and the base of the exponential are different. The property that we're using there is what's called the power property. And what happens is the exponent comes down to the front and becomes a multiplier. That's handy because if I had x squared in here, it's a lot easier to solve something that has 2 times x than it is to solve something that has x squared, right? So that's where that property really comes in handy. Okay? So brings that power down to the front and multiplies. Okay? So there's our 3 properties. Let's get that change of base one. We've seen it already. And that's where we have the log base b of a, and then we have log of, we could be log of a over log of b, or you could do natural log of either one. Most people do log base 10. It doesn't matter though. So that's change of base. Change of base is helpful if the logarithms aren't the same base. Okay, that's where that gets helpful. If the logarithms you're trying to manipulate are not the same base, then change of base gets used. Okay. All right. So what we're going to do is we're going to take these properties, and we're going to. You need to learn them. You probably already know most of them, or you've seen most of them. We did these in Algebra 2. So you've seen these properties before. We're going to take these properties and we're going to do 2 things. The first thing is we're going to expand a logarithm and write it as a sum or difference. Okay, so that's the first goal. Then we're going to take that logarithm that is already expanded and try to condense it into a single logarithm. Okay, so let's start with the first set where we're going to expand the logarithm, and you might see it say write as a sum or difference. So expand the logarithm or write as a sum or difference. That's the instruction. So first example, let's just take something really easy to start with. Log base 2 of xy. Real simple one. What's going on between the x and the y? Multiplying. So that property is going to be property 5 there. So we're going to write this as log base 2 of x plus log base 2 of y. And we have expanded that as far as it'll go. Multiplication turns into addition. Now, let's get a little bit higher level, a little bit more stuff in there. So let's take log base 3 of 3x squared y. So this one has more stuff in it. How many things are inside here? 3 of them. The 3, the x squared, and the y. There's 3 separate things. What's going on between all 3 of them? Multiplication. So I'm going to split that apart into log base 3 of 3 plus log base 3 of x squared plus log base 3 of y. Then I'm going to look at each one of those individually and see if I can do any of the other properties. Okay? Whether it be a simplifying property or a one of the manipulating properties. Okay? So looking at the first one, what can that do? It turns into 1 because the base of our logarithm and that are the same number. So that's going to turn into 1. So I'm going to rewrite that first term as a 1. What does the second term do at log base 3x squared? Yeah, 2 log base 3 of x. Is there anything that can happen to the third one? Yeah, but that doesn't help us any. So we're going to leave it log base 3 of y. And there we have expanded that and simplified it as much as we could. Yeah, but the only time you would need to do change a base is if you have logarithms that are not the same base. So if you had like a log base 2 and a log base 5, and they wanted you to put them together, then that's when you need to do the change of base. But that's not going to come up very often in college algebra at all. Okay. So there we used 1, 2, 3 different properties to do that one. All right, let's do this one. We got log base 5 of x square root of x squared plus 1. All right. So anytime I have a square root or a cube root or some kind of radical inside of my logarithms, the first thing that I do is I change those into exponents. Okay, because I don't have any properties that deal with radicals. I have properties that deal with exponents, properties that deal with multiplication or division. So I'm going to change that into log base 5 of x, and then this x squared plus 1. What is the exponent that a square root turns into? No. The 2 is out here. That's a square root. The index is a 2. What is the exponent for a square root? 1/2 power. The reciprocal. So the exponent for a square root is a 1/2. The exponent for a cube root is a 1/3. Fourth root is a 1/4. Okay. So that's going to allow me to then use my properties that work with exponents on that. Okay. So next step is to split it apart. So log base 5 of x plus log base 5 x squared plus 1 to the 1/2 power. Okay, so this was x times that, so that's why I made an addition. And now what's the last thing that we can do here? Got an exponent on what I'm taking the log of. So that is the power rule, which is property 7 up there. I can bring that 1/2 down to the front. Plus 1/2 log base 5 x squared plus 1. I can't go any further there because I don't have any properties that work with addition inside of a logarithm. I only have properties that deal with multiplication, division, or exponents. The addition in there stops me from doing anything else. All right, let's see if we can manipulate this one. Log base 4, x squared y over w. And I'm okay with you doing more than one at a time. It doesn't matter to me. I typically go straight from the starting spot to the ending spot because I've done so many of them. But you can take as many steps as you want to. Say it again. Okay, yeah, the division one. So that's going to give us log base 4 of x squared y minus log base 4 of w. Okay, that's property 6. That's the division property. That division turns into subtraction. So the numerator is here. The denominator is after the minus sign. Anything from a denominator should have a negative sign in front of it. Okay, with what between them? Addition. So that's going to be log base 4 x squared plus log base 4 of y, and then we're going to still have our log base 4 of w subtracted there. Very good. Yeah, this 2 is going to drop down into the front, and that'd be 2 log base 4 of x plus log base 4 of y minus log base 4 of w. Again, okay, we took it step by step there, one step at a time. If you're comfortable, when you get more comfortable with these, feel free to jump, skip steps, do more than one at a time. I mean, that's you get more comfortable with the properties. It's very easy to do. Okay. That's what we're doing, is expanding that. Let's do 2 more of this kind, and then we'll condense. Let's see. Let's do natural log. A to the 4th, B to the 3rd, C squared, D. Expand that. See if you can do that. So my first question would be, what will have minus signs in front of them?
C.
The C and the D, because they're in the denominator of that. If you recognize that, that's going to help you more than anything else is. Anything that's from a denominator of a fraction should have a minus sign in front of it. So the numerator, that should have a positive sign in front of it, or it'd be just normal. So natural log a to the 4th, b cubed. If you want to split it out one piece at a time, you can. I typically don't do as many steps. In my brain, I did that step. The next step that I would do would be split it apart and do 4 natural log a plus 3 natural log b. I'd do that step together. Minus 2 natural log c minus natural log d. Typically, if I'm working one of these, I usually go straight from here to here, just because I'm so comfortable with the properties. As you get more comfortable with them, you'll be able to do more of that.
That's what I was trying to do, and I read it out, and I was writing it, and I was trying to say it, and I was like,
Yeah, it's some of it's a little bit more complex things going on. Let's get one that's a little bit more complex going on here. Last one of this type. Let's do log base 10 of the cubed root of x squared y. So that's a cubed root there. And x squared and y are both underneath that cube root. We want to expand that as much as we can. It's got a radical in it, so remember what I said earlier about what I do when there's a radical before I do anything else. So that's going to be, if I rewrite this as an exponent, that's going to be x squared y to the 1/3 power. Now, the next thing I want to either think this or write it out. What is the new exponent on x after I do the exponent rules here? So technically that y has a 1 exponent right now.
it's
2/3, yeah. And then the y has what exponent? 1/3. If you will do that first before you start trying to split it apart, that will make things a lot easier for you. Okay? By doing the exponent rules and getting those things, where they have their own exponent, that makes things a lot easier because now I can go straight to my split apart, and I'm going to do the addition and the power rule all at the same time because x to the 2/3 times y to the 1/3, that's an addition. And then I'm going to drop those exponents to the front. So 2/3 log of x plus 1/3 log of y. So by doing those exponent rules all before I started doing the log properties, just using the exponent rules, that makes that a lot easier of a transition into that. And it works pretty well. All right, so expanding, taking one logarithm, splitting it apart as far as you can go. These are typically the most difficult ones because folks don't know when to stop. You stop when you've got it split apart as much as you can. The easier ones to me are the condensing ones because that once you get it into one single logarithm, you know you're done. Okay, so the condensing is easier to me. So that's sure, like with the radicals and all that stuff in it.
Just a difficult one that you would say.
Okay, that's one that I would say is difficult. Okay.
For us, not for you. Let me clarify.
Okay. Let's do. Yeah. You can do it. All right, so this one has the radicals, it has multiplication, it has division in it, it has exponents. This has it all.
Okay, step one, split it apart into subtraction.
So before I would do that, I would write that bottom part as W and Z to what powers?
W to 2/3. And Z to 5/8.
Yeah, very good. That will help you much more than splitting it apart first. All right. Splitting it apart, then we got log or 4 log of x plus 1/2 log of y minus 2/3 log of w minus 5/3 log of z. That's about as long as they get, really. Where you got four or 5 things to do out of that. Not too bad. All right. What's up, buddy?
Travis got a question.
What's up?
Is it still minus when you split them apart for multiplication?
If they're in the denominator,
Yeah.
both of them are going to have a minus.
Okay.
That's why it's 2 minuses there because they're both in the denominator. Anything from the denominator is going to have a minus in front of it. Always. Good question. That's important. All right. Condense. Let's go here. I'm going to put this up and then I'm going to run to a quick meeting here. Log base 2 of 6 plus 3 log base 2 of x. All right. Work backwards and see if you can get that into a single logarithm. See what he can do with that. you back out. They're not here yet. So.
Do you want me to wait in here until they are here, or?
They said they couldn't give it when they showed up.
Okay.
So, I don't know. All right. So thinking about working backwards. Power rules need to be taken care of first. Right. So there's a power rule here. This 3 goes up. So that's log base 2 is 6 plus log base 2 of x cubed. And then addition turns into what? Multiplication. 6x cubed. To me, condensing is so much easier. But it's because you know the properties better now than you did. And it's easier to tell when you're done because you got one single logarithm left. All right, so here we have 1/3 natural log of x minus natural log x squared minus 1. We want to condense that. So again, going to look for power rules first, then anything else. Reason, parentheses, exponents, multiplication, division, left to right, that sort of thing. We're following order of operations is what we're doing. So what does the first natural log turn into? X to the 1/3, or you could rewrite it as what? Cube root of x. And that's what you would want to do at some point, change that into the cube root of x. Whether you do that at the first step in one swoop, get that done, hey, that instead I know 1/3 power is a cube root. So I can just go straight there if you want to. Now, we've taken care of the power rule. Now we look for those addition and subtraction rules. What does the subtraction turn into? So what's on the bottom? Yeah, so we got this big fraction. Got x squared minus 1 on the bottom. On the top, we got the cube root of x. And you condense it into a single logarithm, so you're done. Not too bad. All right, let's get one that's a little bit, got, like 4 parts to it. Because remember, those are kind of like the biggest ones, okay? So let's say we had log base 5 of x minus log base 5 of x minus 3 plus log base 5 of x squared plus 2 minus 2 log base 5 of y. Okay, so that y is going to have the y squared on it. That's good. So I'm just going to note that like that. I'm just going to make that, hey, that's what I got to remember to do that. Now what? So I see some pluses, I see some minuses. So what do I know about the things with a minus? It's going to be from division, and they're going to go where? So anything that has a minus sign should go to the denominator and multiply back together in there. So this is going to be log base 5, and I'm going to have a big fraction. I'm going to have the x minus 3 down there, and then that's going to be y squared. Those two things go to the bottom because they had minus signs on. The other stuff is positive. So positive things are going to go to the numerator. So we're going to have the x times the x squared plus 2. I'll put the x in the front there. And the reason I'm multiplying together in the bottom there is because this would be the same thing if I had log base 5 x minus 3 plus log base 5 y squared. If I had the minus sign out in the front, that would get a minus to both of those. So that's why they're multiplying together in the bottom. Okay. So when you have more than one thing that has a negative sign in front of it, then you know they're going to go to the denominator and go multiply them back together. Out of that. And we've condensed it. It's a single logarithm. We're done. There's not much else to do there. Let's do one more. 3 log x minus 5 log x plus log x plus 5 minus 3 log x minus 2. See if you can condense that. There's my first step. I wrote it out. So what's on top?
X cubed and x plus 5.
What's on the bottom?
X to the x.
That is not x cubed minus 8. It would be, if you're going to multiply it out, it would be x minus 2 times x minus 2 times x minus 2. Don't multiply it out. It's not going to help you. It's just going to be a long process of getting something that's not going to simplify. Now, at that step, you're correct so far, but that's not the final answer. Why is that not the final answer? All of those pieces are in the right spot. But why are they not? Why is that not the final answer? How? And multiplying it together won't make it simplify further. It'll make it actually more complex. That's the same thing as multiplying it out. So no. Look at your numerator and denominator. What is the same? Those have the same base with exponents on them. Okay? So there's 3 x's up top and 5 x's on the bottom. How many get canceled? 3 of them. Where are the leftovers? Top or bottom? Bottom. There's 2 left over. The top part's just got the x plus 5 left over. That is the simplified version of that. So we had to look, there was some simplifying that could happen in there. So that only happens if you have the division. The last one we had with division, there wasn't any of that happening. There just happened to be some on here. You've always got, anytime you end up with a fraction in a problem, you've always got to look to simplify. Okay? Always look to simplify. Okay? That doesn't happen a ton, but it does happen some. So practice day tomorrow, page 456. 13 through 27. So we skip a few and we pick up at 37 through 77 odds on all of those. Okay. So we'll do a work day tomorrow and go from there, kind of see where we're at.